Today in Capechi's Corner, we're going to look at operations with radical expressions. First, we're going to start with some review problems. So in letter A, we have the square root of 36 over 3, and the directions are asking us to simplify. So first, I realize that they divide evenly, so that gives me the square root of 12. The highest perfect square that goes into 12 is 4, so the square root of 4 times the square root of 3. So my final answer there is 2 root 3. In letter B, I have 2 over the square root of 10. I know I can't have a radical in the denominator, so I'm going to rationalize my denominator by multiplying the top and bottom by the square root of 10. So it gives me 2 root 10 over, and the square root of 10 times the square root of 10 is 10. And then I realize I can simplify what's on the outside. So 2 goes into 2 once, and into 10 5 times. So my final answer is the square root of 10 all over 5. In letter C, we have 3 over 4 times the square root of 7 over 3. So I have 3 over 4. Now I'm going to separate my radicals here. That gives me times the square root of 7 over the square root of 3. Again, I'm going to rationalize top and bottom by the square root of 3. Now I'm going to clean it up a little bit. So I have 3 root 21 all over root 3 times 3 gives me 3. So I have 4 times 3, which is 12. Again, I can simplify what's on the outside. So 3 goes into 3 once and into 12 4 times. So the square root of 21 all over 4. Now as we're simplifying the radical expressions, we have some different operations. So number 1, we're adding. And I like to say that when we're working with radicals, it's like working with variables. If I have x plus 3x, my x's stay the same, and that would give me 4x. Right? It doesn't become 3x squared, the x stays the same. It's the same thing when working with radicals. So in number 1, I have root 2 and root 2. They're exactly the same, just like variables. So this is really a 1 in front. So if that helps you, you can write that. So I have 1 and a 3. I add those together. I get 4 root 2. Now in number 2, it's the same idea. I have 2 root 6 plus root 5 minus 6 root 6. I can only combine, which is exactly the same. So I can combine the 2 root 6 and the negative 6 root 6, but I can't combine the root 5. It's similar again to variables. If I had 2x plus y minus 6x, I could only combine what's exactly the same x is. My y is a variable, but it's not exactly the same as an x, so I can't combine it. Just like I can with the radicals. I have root 6 and root 6, which are the same, so I can combine them. So I have 2 root 6 minus 6 root 6, which gives me negative 4 root 6. And then I have my plus the square root of 5, which is my final answer. Let's look at number 3. So I have 4 root 3 minus the square root of 27. Now 4 root 3 I can't simplify anymore, so I'm just going to rewrite that. Minus, now the square root of 27 does have a perfect square that goes into it, that's 9. So I have the square root of 9 times the square root of 3. So I have 4 root 3 minus 3 root 3, which simplifies to the square root of 3. And number 4, again, we have to simplify what we can. And the square root of 24, the perfect square is 4. So I have root 4 times root 6 minus, and the square root of 96, the highest perfect square is 16. So I have the square root of 16 times the square root of 6 plus the square root of 6. So it gives me 2 root 6 minus 4 root 6 plus root 6. So I have 2 minus 4, and then remember there's a 1 right there. So that gives me negative root 6 as my final answer. Now we're going to look at a few other operations. So in number 5, I have negative 4 root 15 times root 3. So I have negative 4. Now remember I can multiply what's underneath, the radical sign. So I have 15 times 3 gives me 45. And so I have to continue to simplify. So I have negative 4 times the square root of 9 times the square root of 5. Remember 9 is the highest perfect square that goes into 45. So it gives me negative 4 times 3 root 5. So my final answer is negative 12 root 5. In number 6, we have the quantity of 3 root 5 squared. And I think the easiest way to do that is just to rewrite it. We know that when I see that square, it means to take everything in the parentheses twice. So I have 3 root 5 times 3 root 5. Now again, remember that means 3 times the square root of 5 times 3 times the square root of 5. So I'm just going to regroup things. So 3 times 3 gives me 9. And then root 5 times root 5 gives me 5. So when I take 9 times 5, I get 45. Now in number 7, I have root 2 times the quantity of 5 root 12 minus root 3. Now I'm just going to distribute that root 2, so I'm going to take root 2 times 5 root 12 and then root 2 times root 3. So it gives me 5 times the square root of 24 minus root 2 times root 3 gives me the square root of 6. So now I'm going to simplify, so I have 5 times the square root of 24 has a highest perfect square in it, that's 4, so I have root 4 times root 6 minus root 6. So it gives me 5 times 2 root 6 minus root 6. So if 5 times 2 is 10, root 6 minus root 6 gives me 9 root 6 as a final answer. In number 8, I have a binomial, root 8 plus root 3, and then I have that squared. So again, I'm just going to rewrite that. I have root 8 plus root 3 times root 8 plus root 3, and it's a binomial times a binomial, so I'm going to use FOIL. So my first is root 8 times root 8, which gives me 8. My outside, root 8 times root 3, so it's my outside, it's going to give me root 24. My inside is also going to give me the square root of 24. And my last is root 3 times root 3, which gives me 3. So now I have some cleaning up to do. 8 plus 3 gives me 11, plus now I have root 24 plus root 24, which gives me 2 root 24. Now I know that root 24 has a perfect square that goes into it, square root of 4 times the square root of 6. So I have 11 plus 2 times 2 root 6. So my final answer is 11 plus 4 root 6.